Introducing Quality Town for Embedded Grade, Gaio Technology's new unit test tool for the AUTOSAR Adaptive Platform. Firstly, let's take a look at what prompted us to develop this tool. Automotive software development is changing. While there used to be separate microcomputers in each device controlling each different function, the growth of automatic driving is leading a shift towards a centralized vehicle computer controlling all functions, mainly due to the huge volume of data processing required for the detection, decision, and operation phases of automatic driving systems. There is also a trend towards using open source platforms for this development as continuous integration becomes more common. But this presents problems for developers. Lots of data patterns means lots of development work and lots of testing, and many of the engineers who are experts at this type of processing do not have experience in the automotive field with its stringent quality and safety requirements and legacy of embedded software restrictions. Also, many of the tools used in the development of algorithms that are central to automated driving are open source. They lack the vendor support necessary for functional safety qualification. So we decided that we needed a new test tool to meet the demands presented by these facets of large-scale development. 3 points we focused on were ease of use in Agile and Scrum-type development systems, suitability for integration with external tools and resources, and the ability to make use of existing test tools and resources. We combined these in a package that helps bring high-quality functionality to the market in a short time. With this background in mind, we developed a new embedded software unit test suite called Quality Town for Embedded Grade, or QTE. The suite is designed with centralized ECU-based systems running large-scale applications in mind. Unit and system testing functions that meet functional safety standards are included, along with the ability to use our existing Coverage Master tool for testing conventional controlled software portions of the system. Automation and optimization of CI/CD testing is facilitated for tools such as Jenkins, and virtual environments such as containers and cloud-based systems are also accommodated. QTE uses existing OSS test tools such as Google Test to execute testing and coverage measurement in a way that satisfies the requirements of functional safety standards. The object code for the target microcomputer is used, and coverage can be measured according to any of the conditions stipulated by the ISO standard 26262. Also, the results are automatically compiled into test reports that meet the evidence requirements of the standard. Google Test, by the way, is the open source testing framework provided by Google, and Google Mock is the stub function generation tool they provide for replacing non-target modules with stub functions for the purposes of the tests. The process is quite simple. Instead of using the OSS toolchain directly, testers use QTE, which controls the toolchain, while the analysis engine in QTE helps the developers make the source code more functional safety ready. The results of each round of tests are prepared in a standard meeting test report format, which project management can use to compare with previous test results to confirm the progress of development. Since QTE can operate the tests automatically, the same process can be used for continuous integration development. Let's examine the testing function in a little more detail. QTE can switch between two modes of execution depending on the purpose of the test. Native execution mode is for testing on a PC while designing the tests and measuring coverage, and target execution mode is for the actual testing on the target microcontroller. This slide shows the structure of a typical target operation. QTE can be run on the same computer as the target system or can operate remotely. The target system is run on a virtual platform and communicates with QTE through a secure shell. And next we'll look at the coverage measurement function and the two test modes it can utilize. The GCC coverage option is designed to use the GCOV open source coverage tool that is part of the GCC package and is used to give quick results in the implementation and debug phase of development, but its results are not detailed enough to satisfy functional safety requirements. On the other hand, functional safety coverage mode uses static analysis of the source code to give highly detailed test results meeting the requirements of functional safety standards. Another feature of the coverage measurement function is the treatment of C++ templates. Usually when using a template, multiple objects are created from the same source code, so coverage of the objects may not be complete, even though the source code coverage is complete. QTE overcomes this issue by measuring the coverage of all object code. Let's see how these test and measurement modes can be combined. Combinations of the native or target execution mode with the high-speed or detailed coverage measurement mode give a range of possible tool pairings that suit each phase of the testing process. Next, we will take a look at the functional safety option. The QTE functional safety option analyzes the source code to find unreached code and can add assertion code to improve the coverage for these areas. Impact confirmation is a comparison test carried out to confirm the correct effect of the assertion code. That is, coverage is improved with no effect on the expected values in the results. Impact confirmation can also be used to confirm that the native execution and target execution produce the same results and that code optimization has no effect on the expected results. The final stage of the process is the report creation, all of which is done automatically. These reports can be used as evidence in reviews or through comparisons with previous results or other projects as indications of development progress. These are some examples of the reports generated by QTE that summarize the tests done. Test reports can be generated for each source file and each function. Moving on to the certification of the tool suite for functional safety. QTE was certified as compliant with Automotive Functional Safety Standard ISO 26262 and the more general Functional Safety Standard IEC 61508 in March of 2021. Next, let's take a look at what improvements are coming in the future. Report generation will be improved to integrate reports from multiple workspaces, which are common in large-scale development projects. This is included from version 1.2 released in June 2021. Also being prepared is an automatic check of the settings files to detect any errors before the tests are run, customizable XML reports, and the implementation of additional target environments. Let's finish up with a summary of what we've learned today. Quality Town for Embedded Grade allows effective, efficient, automated testing for large-scale software projects using existing testing environments and OSS test resources. Users do not require any specific embedded or automotive experience or skills to use the tools, and the QTE tool is certified as compatible with the ISO 26262 standard, making it much more valuable in the field of software development based on a functional safety lifecycle. Finally, to introduce some other upcoming features of the QTE tool suite. Future versions of QTE will see improvements in static analysis, test data creation, security testing, performance measurement, and support for other coding languages. More information on the full range of test tools from Gaio Technology can be found on our website. Thank you for your time and attention.